here we're beginning sample test 3. Unlike the previous test where we could do it on paper, I could give you partial credit based on things. The following tests, test 3 and test 4, are going to have to be online given the situation. So what I've done is I've created a sample test and an actual test. The sample test has questions like the actual test, same order, same general design of the question. They'll just be different formulas and different numbers plugged in. So here, when I'm going to go over the sample test, these sample test questions might not look exactly like yours because there's times where there's random numbers put in instead of the step numbers I have, but you're still going to be able to follow through the process the same way I do it here. So the first question on the test is going to be find the critical numbers of a function. Remember that finding critical numbers really amounts to setting the derivative equal to 0 and solving for x. So the first thing I have to do here is find f prime of x. When I go to take the derivative, 2 comes down, this becomes 12x. The x goes away, this becomes minus 5. I don't, off the top of my head, know what makes 12x minus 5 0. So what I'm going to do is solve the equation 0 equals 12x minus 5. Add 5 to both sides, and I get 5 equals 12x. Divide by 12, and I get x equals 5 twelfths. For the second problem, it asked me to find the absolute extrema of the function on the closed interval. When I'm finding absolute extrema, I need to test 3 things. I need to test each endpoint, given that they're included, which these are based on the bracket, and I need to test any critical numbers. So the first thing that I'm going to do is I'm going to take the derivative, set it equal to 0, and use that to find any critical numbers. F prime of x here equals 3x squared minus 3x. I can take a 3x out of both things. That makes it 3x, x minus 1. What makes this 0 is 0. What makes this 0 is 1. So we now have 4 numbers that we have to test. We have to test the left endpoint, -3. We have to test 0. We have to test 1. And we have to test 10. When I say we have to test them, what I really mean is we need to put those numbers into the original formula, see what we get back for y. So I'm going to find f of -3, f of 0, f of 1, and f of 10. For all of these, I really want to have a calculator handy, so let me go get my calculator. When I'm doing 4 things like this, it probably helps if I put into the y equals my original equation. So here I'm going to put in x to the power of 3 minus parentheses 3 divided by 2 and parentheses x to the power of 2. I press graph just so that I can see a graph, but now what I really want to do is press second calc value. First value I'm going to put in is -3. It tells me the answer is -40.5. I can do this without graphing, without y equals, simply by putting -3 into this equation. So -3 parentheses cubed minus 3 halves parentheses -3 squared. But either way will get you the same answer. If I now calculate the value when x equals 0, I get y equals 0. If I calculate the value when x equals 1, I get y equals -0.5. And if I calculate the value when x equals 10, I get positive 850. So the first thing I did was I found what the critical numbers were. I then made a list of each of the critical numbers and the 2 endpoints of the interval since they were bracketed. I look for what each of these x values would produce as a y value in the original equation. I then am going to star the largest and smallest. This is the smallest, this is the largest. So this has an absolute max when x equals 10 and y equals 850. This has an absolute min when x equals -3 y equals negative 40.5. So these would be relative mins and maxes that the equation, or I'm sorry, that the problem doesn't ask for. The absolutes are just the largest and smallest value I say.